So I wanted to make a video about the blizzard of '96. We just had the 17th anniversary of it, and wanted to talk about what made this storm so special, how it was so unique, the factors that went into making for a tremendous amount of snowfall, and also why it will never happen again. Um, Things that occurred just won't occur like the way they did with that storm. Firstly, here in satellite imagery, you get to see a thing of beauty, moisture coming out of the Gulf, the Atlantic. You see that with all snowstorms, really, but it's just always a thing to marvel at. Jumping right into it, the snow totals are, of course, what's in question here. Why were the snow totals so much bigger for '96? Well, to compare two storms here, I'm going to go with '96 and '83. Now, in '96, you see this big area of 20 to 30 inches and these extended pockets of 30-inch to 40-inch amounts, including southeastern PA and our region as well. The next most comparable storm that was, a big blizzard for the big cities was the blizzard of '83 in February, and Megalopolis blizzard it was called. And here you see a 20 to 30-inch area, but it's not nearly as big, and there's only isolated pockets of 30-inch amounts. Now, to compare these storms, because there are some similarities, there are some differences too. '83 occurred during a strong, very strong El Nino. Actually, it was the only storm that winter of any significance, whereas '96 occurred during a weak to moderate La Nina, and that was a very snowy winter. But that really doesn't get into why this was worse with '96. Now, the North Atlantic Oscillation, the NAO, both were negative, '96 and '83, and they were trending towards, sharply trending upward. '96 made it to positive by the end of the storm, whereas '83 only made it to a neutral level. Next thing to look at is track, and this is where we start honing in on some differences. The actual direction of the track, the trajectory, is pretty similar. 1983 storm, you see it come out of the Gulf, you see it come up the East Coast, and it makes the right hook off the Delmarva, like our biggest snowstorms always do. You see some, steady strengthening there. Now, blizzard in '96, again, out of the Gulf, and then once you see that coastal pop in North Carolina, you see those dots are much closer together. And what that means is that it was going through rapid intensification while going very slow before it made that right hook, and actually then began to weaken. But both storms were Miller Type A storms, which means that they didn't have any redevelopment. They were just storms that came up the East Coast, whereas Miller Bs, there's a primary low, whether it's back in Ohio, and then there's coastal redevelopment. And this is from a case study I did several years ago. All these storms basically go through the same zone. I label it the G spot here with all the different tracks of all the biggest storms that have hit the area. And basically, they all show that that's the area you want to get the snow, you want the low to track through. And they all do have that right hook to some degree. Now, looking specifically, zoomed in at each storm, what you see here on the '83 storm is something very important. In a 24-hour period, the storm goes all the way from the South Carolina-North Carolina border all the way to Cape Cod, 12Z to 12Z. And that was a significant storm, dropping 20 inches. Now, this is where '96 is a bit different. You see that coastal pop there, Outer Banks, 12Z. The next 12Z you see there, 24 hours later, the storm has only made it to the Delaware, Maryland shore border. So it went through it barely moved, and it was going through rapid intensification that whole time period. And that can be seen here on the general track. You see that it coming out of the Gulf, it's at a steady pace. Then all of a sudden you get the coastal pop, and it slows down dramatically, and it strengthens incredibly from 1006 down to 978. The question is, why did that happen? I'll get to that more in a minute, but other things to think about with snowstorms: high pressure, or cold air source. In '96, you had a 1040 high out in the Great Plains, and you had a 1030 high across eastern Canada, exactly where you'd want it to be, perfect banana high setup. 83 did not have that westerly component, but again, the more important of the two regions is to have that high pressure in eastern Canada, and it did, a 1040. That's very strong high in Quebec. So both storms had that, and comparing that to the case study that I did, you can see they're right in the zones that they need to be. It was higher than the 1034 average for 83, and obviously higher for the blizzard of 96 in both zones. So the cold source wasn't the problem, or any sort of difference between them. Another thing to look at is 850 low track. This is a few thousand feet up. Usually where rain snow is decided, but wherever the 850 low tracks, usually what you see is parallel to it, about 200 miles, is where you get the heaviest snow. The blizzard of 96, you see, it comes out across Virginia, then to the Delmarva and out. And sure enough, you see the heaviest snow stretching into Pennsylvania there. And here, blizzard of 83, different source. It comes up from out of the southeast, but again, it hits the Delmarva and then goes out, and you see that axis of heavy snow is basically in the exact same spot. And that's why 850 low tracks are so important in determining who's getting snow and heavy snow, and all the snowstorms that we have in our case study that I did. You could see they all go through this little zone here of where you want an 850 low to track to get the heaviest snows 200 miles away into Berks County. But let's get to why the storm slowed down and dramatically in that zone. Firstly here, what I want to show is, obviously we have the banana high, and we have the low pressure coming out of the southeast, but I put in dashed blue there, the 500, the upper level feature that was digging in. Basically, this is the jet stream phasing in. Now, the jet stream here now closes off, so you got a closed off low, upper level low, and it starts interacting with the coastal low. And basically it does so, it acts like a magnet. It pulls towards it, but yet pushes it away. It's very awkward. It's called the Fujiwara effect. But basically, as it digs in, it forces the low, instead of going northeast, to go due north, and to do it in a very slow fashion. And now this whole time, it is rapidly strengthening. Now what you see is, after it gets to the coast of New Jersey here, the 500 low begins to weaken, and that actually allows for separation from the upper level low, and it actually can begin to pull away then, and then it does after that. In regards to how this storm was forecasted, it was not forecasted very well. Firstly, at the time, this is Glenn Hurricane Schwartz, 3 to 6 inches in Reading, Allentown, 6 to 12 in Philly, and then it was supposed to be a southern storm, Washington, D.C. south, 12 inches plus. There was known for great potential to be there, but the American computer models especially were pushing for the southerly track. The European, which was in its infancy at the time, really was the one pushing for a further north track, and this is the storm that sort of made the European famous. Winter storm warnings were put out, obviously, because winter storm level snow was expected, and there's that track that was forecasted. One thing you don't see there is that due north track from Hatteras to Delmarva. You don't see that there. And that's something that just couldn't be anticipated by the models at the time. But the general idea was you would have a snowstorm come through and come up, track, the way that it was shown there, and then the heaviest snow would be across D.C., southern Jersey. And even at this point, this is getting to be the night before now, 6 to 12 inches for our area, 10 to 20 down in Philly, higher amounts down in Washington, D.C. Now, it didn't play out exactly like that. At first, everything looked fine in regards to that forecast. This would be Saturday night, Sunday morning. You see where the snow is falling, low pressures coming out of the Gulf, new low pressure forming near South Carolina, North Carolina border, and sure enough, the heaviest snow right where it's expected to be, in Virginia, and then lighter snows are beginning to make it up into Pennsylvania. Going forward, basically what you see is the snow shield expanded rapidly in size, and the low was consolidated into one low that was, over South Carolina, and that began tracking, slowly northward, northeastward. And the snowfall rates were incredible initially. You know, you're talking 2 to 3 inches an hour, and it was just piling up in places like D.C. and Philly. But even right away, you could start to see Delaware. Why weren't they getting the heavy snow? That's because they were actually starting to have mixing problems, and that was due to the fact that the low was beginning to track too close. And that can be seen here once the low gets to the Outer Banks. You can see that rain line is actually starting to infringe upon southern Jersey and the Delmarva Peninsula, and that's why snow totals at that point were lower there than they were just inland. It was about this point that things began to be clear that there'd be a problem further north, and it was the only time we'd ever been put under a blizzard warning in our region. Snow totals then were showed to reflect heaviest going through the I-95 corridor, with just a touch less north and west, and then a touch less towards the beach with mixing issues. But the storm did not cooperate. It kept coming a little bit further north because it was going due north due to that 500 low association that I'd showed earlier. And at this point, it's just barely moving over the Delmarva. Snow totals here. This was what from Action News, and this is when things began to just spiral out of control. State of emergency. You were not allowed to drive. All roads were closed. It went till 12 noon Monday, but eventually got extended for the whole day, and that's because this is kind of what it looked like. You had snows that, cars that were just abandoned and people walking, and the wind chills were 20, 30 below while it's, whiteout conditions, and it was just horrific. But you do see that the snow, was basically in the areas it was supposed to be, a little bit further north, indeed, but still the heaviest snows go through the I-95 corridor. Now, what happened next is, how did we, our area, 60 miles northwest of the big cities, actually make it to the same amounts that they got, the 30-inch amounts? And you can see that the lows, still basically over the Delmarva, coming up to New Jersey, heavy snow blasting the whole time. People are looking at the snow totals, and they see 18 to 24 in our area, 25 to 32 down in the I-95 corridor. How did we end up with 30 inches? Because those places only ended up with like 31. Philadelphia Airport, for example, the official place that they measure, ended up with 31 inches of snow, at which point we had 20 or 22. So how did we catch up? Well, that was where the end of the storm really tells the tale, and this image shows it. Basically, the low is up to New Jersey now, and all the snow that's coming behind it is backlash snow, that snow in Pennsylvania, and it really wasn't affecting the areas that had been hardest hit. It was affecting areas to the north and west. Now, here's a list just to give you an idea of how, there's some gaps in the data here, but snow was falling from 6 a.m. on Sunday, and it was still snowing around 2 p.m., 12 noon on Monday. And that gives you an idea here, and most of that time was just, heavy, moderate to heavy snowfall. But to give you a better idea here, here's the radar imagery from the time period. And you can see as the storm moves in, initially the heavier snow, represented by the brighter greens, is in Philadelphia. It does make it up to our way. Some dark patches there have heavier snow. But the heaviest, that darker green, is over Philly, at least initially. And that's when they were piling up the snow totals and getting up to, 15 inches while we had 6 or, something of that nature. Now, that brighter area you saw there for a bit, that was when it started mixing in, and all of a sudden we get to this point where it looks like the storm's kind of over. There's these big gaps, things are becoming blotchy. But this is when that upper level feature kind of digs in. This is when it happens right here. It digs in and it re-energizes the storm, and what you get is these bands of very intense snowfall. But where are they actually setting up? Some of them are going through Philly in the areas that have been blasted, and you see them right there. But there's also very heavy bands forming over the northwestern part up to our area, and that's what you see right there. And for a period of time there, Philadelphia goes through a bit of a snow hole. Meanwhile, we, in this backlash snow, due to the cold that has settled in, start getting tremendous snow ratios to the point where this stuff has a tremendous fluff factor, and it just piled up. And that's how you get from 20 to 30 inches to make up for that difference. And it was just a remarkable storm that overperformed in a way that no other storm ever will.